Okay, students. Now we will speak about the chapter motion in one dimension. We are going to speak about motion in one dimension. What do you mean by one dimensional motion? The motion which is in a straight line, it is otherwise called as one dimensional motion. It's because any one axis is required for representing these types of motion. As we know, in our rectangular coordinate system, there is x, y, and z axis. In this, any one of the axes is required to represent the motion in a straight line. That's why we are saying motion in a straight line as a one-dimensional motion. Okay, therefore, motion in a straight line is called as one-dimensional motion. It's because any one axis is required to represent the motion. Okay, then let's understand what motion is. What's motion? When can we say that a substance is at motion? We could say a substance is in motion if its position is changing with respect to time. If the position of a substance is changing with respect to time, the substance is in a state of motion. Okay. Therefore, we are going to understand in detail about motion. In order to understand about motion, we require the physical quantity, distance, displacement, velocity, speed, acceleration, etc. In order to speak about distance and displacement, let's speak about distance and displacement. For that, let's have 2 points. There's a point A and there's a point B. Then, if a substance is traveling from A to B like this, he is traveling, or assume a person is traveling from A to B in this path. Then the total path covered by the substance is the distance. The total path covered by this person is the distance. If you are assuming this as a string, then if you are extending the string, the length of that string will be the total path covered. Okay. Therefore, the total path covered by the substance is the distance. Then if another person is traveling like this from A to B, the second person is traveling from A to B like this, is the two distance same? No, we could clearly see the black color path is more when compared to the blue color path. Therefore, if this is the first person and this is the second person, means first person is traveling a greater distance when compared to the second person. But their initial point and final point are same, but the distance is not same. Okay. Therefore, the total path covered by the substance is distance. Its SI unit is meter. The dimensional formula is L, and it is a scalar quantity. What's a scalar quantity? Those physical quantities which is having only magnitude, they are scalar quantities. Therefore, distance is only having magnitude, there is no direction. Therefore, distance is a scalar quantity. Now we know what is distance. Let's speak about displacement. Displacement is the shortest distance from initial point to final point. What's displacement? It is the shortest distance from initial point to final point. Okay. Therefore, in order to mark displacement in this situation, let me use green color. If you are drawing a straight line from A to B, this is the displacement of the substance. The shortest distance from initial point to final point, that is this green color line, is the displacement. Displacement only depends on the initial point and final point. It is independent of the path traversed by the substance. Therefore, what we can say is the displacement of this black color curve and the blue color curve is same. That is, if a person is traveling through the black color path to reach B, and another person is traveling through the blue color path to reach the position B, both of them are having same displacement since the initial point and final point is same. Clear? Therefore, we could say displacement is a vector quantity. Why are we saying displacement is a vector quantity? It is because displacement is having both magnitude and direction. The SI unit of displacement is also meter, and the dimensional formula of displacement is also L. That is, the SI unit and dimensional formula for distance and displacement both are same. Their SI units and dimensional formulas are same, but that doesn't mean that the two physical quantities are same. They are two entirely different physical quantities. One is a scalar quantity and another one is a vector quantity. Which is a scalar quantity? Distance is a scalar quantity. Displacement, it is a vector quantity since it is having both magnitude and direction. If I am just giving as an example, let's say the total path covered by this black color curve, let it be 30 meter. Okay, let's assume that this is 30 meter. The total path covered by the blue color curve, if it is 25 meter, from diagram it's clear that this black color curve is having more length than the blue color curve. Then the green color straight line, let's assume that this is 20 meter. Then first substance, the distance is 30 meter. 30 meter is enough. If you are saying the first person's distance is 30 meter, the data is complete. That is, distance is only having magnitude. The magnitude is 30 meter. If we are saying the second person's distance is 25 meter, that's also a complete data. That is, 25 meter is the magnitude of the distance of second person. There's no direction. But if you are saying 20 meters the displacement from A to B, that data is not complete. Why? 20 meter will give only the magnitude. You should say 20 meter from A to B towards right. Okay, then the data is complete. That is 20 meters the magnitude and towards the right it is the direction. Therefore, displacement is having both magnitude and direction. It is a vector quantity. Therefore, now we know what is distance and displacement. Now let's understand what is velocity. In order to understand velocity, let us say at initial time, that is at t is equal to 0 time, the position of a substance is at 0. At t is equal to 0 time, the position of a substance is at 0. Then at a t1 time, that is after 2 seconds, the position of that substance is changing to 10 meter. Let's say 10 meter. Then after 4 seconds, the position of the substance is changing to 20 meter. After 6 seconds, the position of the substance is changing to 30 meter and the substance is traveling like this. If we are analyzing a substance motion, at initial time, the substance is having a distance of having a position of x is equal to 0. After a 2 second time, from initial time, we are having a position of the substance at 10 meter. At a third time, that is at 4 seconds, the position is at 20 meter. At 6 seconds, the position is at 30 meter. Then, in this case, the velocity is change in position divided by change in time. That is, if they are asking you velocity at t is equal to 0 to t is equal to 4 seconds. If they are asking you velocity from t is equal to 0 to t is equal to 4 seconds, then we will have to use this formula and we could write v is equal to delta x means final position minus initial position divided by final time minus initial time. If this is x1, let me write this as x2, x3 and all for the purpose of communication. Okay, therefore this final position is the initial time, that is t1 is 0. In this question, if you are referring, the initial time is t1 and that is 0. And the final time t2, it is 4 seconds in this question. Then the initial position, that is x1, what is the position at t is equal to 0? You could see it is 0, therefore x1 is 0 in this situation. Then final position, that is at t is equal to 4 seconds from our current situation, the position will be what? 20 meter. Okay, therefore it will be 20 minus 0 divided by 4 minus 0, that will be 20 by 4, that is equal to what? You will get 10 by 2, that is 5 meter per second. Okay, therefore 5 meter per second is the velocity. Then if I am asking you the velocity from t is equal to 4 seconds to t is equal to 6 seconds, we could say v is equal to x2 minus x1. If the time is from 4 seconds to 6 seconds, we could say final position will be 30 minus initial position, it will be 20 divided by final time, it is 6 and initial time it is 4. Therefore 10 by 2, that is equal to 5 meter per second itself. Therefore in this situation, what we can understand is, if you are taking any time interval to find out the velocity, the answer for velocity will be 5 meter per second. Then let me speak about velocity. Velocity is the rate of change of displacement with respect to time. Velocity is the rate of change of displacement with respect to time. Rate of change of displacement with respect to time. Okay, therefore what is velocity? It's a vector quantity. Velocity is a vector quantity. Velocity will have both magnitude and direction. It will have both magnitude and direction. The SI unit of velocity, it is meter per second, and the dimensional formula is LT raised to minus 1. The SI unit of velocity is meter per second and the dimensional formula is LT raised to minus 1. Hope you have understood up to this. Then let's move on to our next page, where we are going to draw a graph. I'm going to draw a graph. That is, in this graph we will have time along the x-axis and the position along the y-axis. This graph is called as displacement time graph. What is this graph called? It is called as displacement time graph, or it's otherwise called as position time graph also. A graph with displacement along y-axis and time along x-axis, it is called as displacement time graph. Okay, and if I am drawing a graph corresponding to our previous situation, that is 0 to 4 seconds, positions are 0, 10, 20, 30, then the graph will be a straight line. That is, if I am representing that situation in a graph, let's say this is the 0 time, and let's say this is the 2-second time, 4-second time, 6-second time. At 0 time, the position was 0. And next, at 2-second time, the position was over here. At 4-second time, the position will be somewhere over here. At 6-second time, the position will be somewhere over here. Then, if you are marking the points from the previous question, at 2-second it was at 10 meter, at 4-second it was 20 meter, at 6-second 30 meter. Therefore, let me mark it over here. 2-second it was what? 10 meter, 4-second 20 meter, and 6-second 30 meter. We have calculated velocity by using the formula delta x by delta t. And if you are calculating the velocity from 0 to 6 seconds, if you are calculating the velocity from 0 to 6 seconds, it will be what? This distance. That is, if you are calculating the velocity from 0 to 6 seconds, then we will have to consider a triangle like this, a triangle like this, and this distance, it will be, this distance will be what? 30 minus 0, that is 30. This will be, this distance will be 6 minus 0, that is 6. Then velocity will be 30 by 6, and it is what? 10 by 2, that is 5 meter per second, as it is in the previous problem. What I am going to communicate over here is this 5 meter per second, it is the tan theta value if you are considering the theta angle over here. This will be tan theta value. That is, we could say velocity is delta x by delta t, that is tan theta. What is tan theta? If you are imagining from our previous max classes, we could say tan theta is the slope of this line. What is tan theta? Tan theta is the slope of this line. Therefore, if you are taking slope of the displacement time graph, we will get velocity. That is an important point. Velocity can be obtained by the slope of the displacement time graph. Slope. Okay. Slope of displacement time graph will give you velocity. That is, the tan theta value of this triangle will give you the velocity. And it is clear that if you are taking a triangle like this, if you are assuming a triangle like this, and if this angle is theta, this angle is also theta, and if you are taking the tan theta value of the smaller triangle, that will also give you the same answer. That will also give you the same answer. If you are comparing with our basic max, since this angle, this angle, this angle will be equal, it's because this is a straight line. Therefore, the average velocity at any situation will be same. That is, the velocity between the time interval 0 to 6 is 5 meter per second. The velocity between the time interval 0 to 4, it is also 5 meter per second. The velocity between the time interval 10 to 20 or time interval 2 to 4, it is also 5 meter per second. Therefore, this substance is having a uniform motion. The substance is executing a uniform motion. That means the substance is moving with a constant velocity. The substance is moving with a constant velocity. Therefore, this is the basic idea that we have to understand. Average velocity is delta x by delta t. It can be obtained by tan theta or slope of the displacement time graph. We could find out velocity from slope of displacement time graph. We could find out velocity from slope of displacement time graph. Then let me have a different situation, or in this situation itself, if I am saying what is the velocity between 0 to 6 seconds, it is actually 5 meter per second. What's the velocity between 2 to 4 seconds? It is 5 meter per second. What is the velocity at the second? It is also 5 meter per second. What is the velocity at the fourth second? It is 5 meter per second. Therefore, the instantaneous velocity and average velocity is same in this situation. That is, if you are taking the average velocity between any two time interval, and if you are finding out the velocity at a particular instant, that are both same. Okay, but it's not same in all situations. I'm saying the velocity, that is instantaneous velocity and average velocity, is same in this particular situation. That doesn't mean that the velocity, instantaneous velocity, will be same in all situations. In order to understand that clearly, let us have another graph over here. We are having another displacement time graph over here. For drawing that, let's say time is in this axis and the position or displacement is in the y-axis. Therefore, now in this particular situation, let us have our displacement time graph like this. Is this a straight line? Now you could clearly see it is not a straight line. Yes, this is not a straight line. And let's define the points. Let's say this point is 0, this point is our 2, this point is our 4, and this point is our 6. Let me change the 4 slightly. Eraser. Let this point be our 4. Okay, then compare with these two graphs. Are they same? No, they are not same. They are not same. This is a straight line while this is a curve. This is a curve. Okay, therefore in this situation, if we are finding out the velocity, they are asking you the velocity. And in this situation, let's say they are asking you the velocity at this particular, let me use another color. They are asking you the velocity at this instant. If they are asking you the velocity at this instant, what we can do is we could find out the velocity by using this formula. We could use the velocities formula like this. And in order to find out the velocity at this particular instant, let's take one point over here and let's take another point over here. Then let us draw a triangle like this. If we are constructing a triangle, and if we are taking the tan theta value of this triangle, let this be the theta, and if you are taking the tan theta value, you will get the velocity. Is that velocity exactly equal to velocity at this point? The answer is no. But in this situation, if you are taking the tan theta value of this largest triangle, that value is 5 meter per second, means the velocity at this particular instant, that should be also 5 meter per second. But this is not the case in this particular graph. Why? It's because this is not a straight line. This displacement line graph is not a straight line, it's a curve. Then there is another method for finding out velocity. That is, we could imagine the two intermediate points. Let's have another color. We could imagine the two intermediate points like this. Then let's construct a triangle with these two intermediate points like this. Then if we are taking the tan theta value of this orange triangle, that will also give you the velocity. Which velocity will be a good one? That is the tan theta value of this red color triangle or the tan theta value of this orange color triangle. Now we can say the tan theta value of this orange color triangle will be a little bit more nearer to the velocity at this particular instant. Then let's take another 2 points. If I am taking another 2 points which are very near to the central point that is marked over here, and if we are constructing a triangle like this, now the answer will be much more accurate. It will be much more accurate. Okay. Then what are we doing in this case? In this case, the initial time interval was up to this value. Then the second time interval was decreased. In the second situation, we decreased the delta t value. In the third situation, we further decrease the delta t value. Then the violet triangle tan theta will be giving you a much more better result. Then if you want a much more accurate value, then what you have to do in this case is you will have to construct a triangle with the nearest point like this. Then it will give you a much more accurate answer. That is, we will have to decrease the time interval. We will have to decrease the time interval. Then the most accurate answer will be the delta x by delta t value with the lowest delta t. We are finding out the delta x by delta t in each case. Tan theta means the change in position divided by change in time. But the delta x by delta t value with the lowest delta t will give you the accurate answer. Lowest delta t will give you the accurate answer. Therefore, there is a representation for that in mathematics. If you have to say the delta t value which is very low, and at that time the delta x by delta t will give you the most accurate value of velocity at that particular instant, means the mathematical method of saying that is limit delta t tends to 0 delta x by delta t. I'll repeat this. This you will be learning in your +1 max, but not now, in some chapters or 6th or 7th chapters and all. But we are requiring this in math, the physics. Therefore, I'm saying if you are seeing like this, you should understand it is limit delta t tends to 0 delta x by delta t. Limit delta t tends to 0 delta x by delta t. What this means is the delta t values decreasing, and it is tending to become 0. It's not actually becoming 0. It is tending to become 0. And at that instant, the delta x by delta t value is the most accurate one. And that is called as dx by dt. Can you remember this dx by dt? Yes, this is derivative. Therefore, this is the connection with differentiation in our physics. Limit delta t tends to 0 delta x by delta t, it is called as dx by dt, and dx by dt is the instantaneous velocity, therefore v. Therefore, we could find out instantaneous velocity by the formula dx by dt, that is limit delta t tends to 0 delta x by delta t. Let me summarize this. That is, there is two types of velocity: average velocity and instantaneous velocity. Average velocity is the delta x by delta t between two different time intervals. Delta x by delta t between two different time intervals. Instantaneous velocity is the velocity at a particular instant. For a uniform motion, the average velocity and instantaneous velocity are same. But that's not the case of a non-uniform motion. Instantaneous velocity is having a mathematical expression as v is equal to dx by dt, that is equal to limit delta t tends to 0 delta x by delta t. Dx by dt is the rate of change of position with respect to time. Rate of change of position with respect to time. You just have to understand the basic thing over here. Rest all things you will be learning in mathematics. Okay. Therefore, this is the formula for finding out instantaneous velocity, and this is the formula for finding out average velocity. Instantaneous velocity, I've said the tan theta value of the smallest triangle, or we could say instantaneous velocity like this also. That is, if you are imagining a tangent drawn from that point. Let me have this line over here. This line is the tangent drawn from that point. This line is the tangent drawn from that point that we have initially marked. The slope of this tangent, the tan theta value created by this tangent, will give you the instantaneous velocity. How can we find out instantaneous velocity from the displacement time graph? Slope of the tangent drawn from that curve, or slope of the tangent drawn from that point. Slope of the tangent drawn from a particular point will give you instantaneous velocity. We will stop this video and we'll continue about this in our next video. Okay.